Okay, so let's look at examples 3 and 4. A plane is flying in a southeasterly direction. So the plane is flying this way. All right, a headwind for the plane would be what kind of wind? Well, a headwind is blowing into your face. A headwind is blowing that way. And we always talk about the direction that the wind is coming from. So if you're right here, the wind is coming from this direction. That is southeast. So the headwind would be a southeast wind. The tailwind for this plane is the direction the wind is coming from. It would be kind of blowing this direction from the northwest. So this would be a northwest wind. So again, that's a little counterintuitive. You have to understand how the naming system of winds works. Let's look at example number 4. All right, so a plane that averages 540 miles per hour in still air. That's one way of saying it. Sometimes we'll say in still air. Sometimes we'll say relative to the wind. Okay, this is just saying this is kind of the baseline speed of the plane. It flies 540 miles per hour in still air, and it's going from San Francisco to New York, which are 2,600 miles apart by air. If the plane flies with a tailwind of 90 miles an hour, how long is the trip? Okay, so here's my plane. It's going west to east, and it's going 540 miles an hour. And then I also have a tailwind. Now remember, vectors don't necessarily have starting points, so there's little 90 mile an hour winds all throughout the route, but each one of these is a 90. So if the plane's flying with this tailwind, it's got 540 miles an hour plus the 90 miles an hour. So together, it's going 630 miles an hour, right? Which is the 540 plus the 90. All right, how long is the trip? Well, to figure that out, you have to remember that speed equals distance divided by time. Here, we're trying to figure out how long the trip is. We want to know what time is. So I'm going to take my speed, which is the 630 miles an hour from here. I'm going to take my distance from the question. And I want to solve for time. So I do a quick switcheroo, and I get t equals 2,600 divided by 630. When I type that into my calculator, I get 4.13 hours. Now, we never like to use decimals with hours. We like to convert to hours and minutes. So I just take that 0.13 times 60 over 100, and I get, roughly speaking, 8 minutes. So the best answer here is 4 hours and 8 minutes, written best in clock format. All right, so going from San Fran to New York, 4 hours and 8 minutes. What about if I'm going from New York back to San Francisco? And I've got the same wind going. So this time, I'm traveling this direction. Same plane, so 540 miles an hour, but the wind is still going west to east. So this time, it's knocking me back 90 miles an hour. So on balance, I'm going this direction, but I'm going 540 miles an hour minus the 90 miles an hour. I'm only going 450 miles an hour. I set up the same equation. I'm using speed equals distance divided by time, but now I've got 450 equals 2,600 over time. Do the old switcheroo and do the division. And I get 5.78 hours. So that's a lot more than 4 hours and 8 minutes. And a 90 mile an hour tailwind isn't that unusual. I mean, that's something that happens quite a bit. Again, to convert the 0.78 hours into minutes, I multiply by 60 over 100, and I get roughly 47. So 5 hours and 47 minutes versus 4 hours and 8 minutes just because of the impact of the wind.